So we're going to close the session with our final keynote of the day, but just a quick announcement, and we'll have a couple announcements afterwards too. But here is our feedback form. We do take your input very seriously. We've changed quite a bit over the 11 years that we've done this, largely because of what goes on these documents. So sorry for the paper, but we found that paper actually gets more people involved. And we do have a drawing at the end of the day. We'll draw a name out of a hat and give somebody, I can't remember the exact value, but an Amazon gift card. So please do fill one out. So as our final keynote for the day, starting here in just a minute, I want to introduce Alberto Cairo. Alberto Cairo is the Knight Chair in Visual Journalism at the University of Miami in Florida, not Ohio, which is good to know. He's also the director of the visualization program at the University Center for Computational Science. Alberto has presented for us 4 years ago, correct? And he's written several books, and one is coming out here later in the year called The Art of Insight, How Great Visualization Designers Think. And he's got 3 other books: How Charts Lie, Getting Smarter About Visual Information, The Truthful Art, Data Charts and Maps for Communication, and The Functional Art and Introduction to Information Graphics and Visualization. So definitely Data Viz Pro, Alberto Cairo.
Well, it's good to be back. It was only 4 years ago, but it feels like 40 or something like that, because it was right before the pandemic. In any case, I'm going to talk a little bit today about the language of data visualization, about the way that I teach and speak and think about data visualization, perhaps with the hope that you will be able to borrow some ideas that you can apply to your own work. So 4 years ago, when I came here to present, I talked about my previous book, How Charts Lie. Perhaps some of you attended that talk, so I talk a little bit about how charts can mislead us, how we misread them. Today, the topic is completely different. It is related to the way that my thinking about data visualization has evolved, how I have changed as a professional, and also as the effect of writing that book. Right, the new book that is coming out in November, The Art of Insight, which essentially consists of a series of conversations with visualization designers, right, to see how people do things and why they do things the way that they do things. So I have talked to data scientists, to journalists, to data analysts, to scientists of many different kinds, and my thinking about visualization have changed. There are certain things that have not changed, though. So I still teach many core principles of visualization that have not changed. I also try to sort of like encourage my students to get deeper into data visualization, because there is value in learning data visualization, right? I see data visualization in many ways the same way that I see written language, right? It's a tool that we can use not only to communicate, but also to think clearly, to express ideas, to analyze information, to explore information, to extract meaning from the information. And I also, as long as I come from a program in journalism, I also try to show my students examples of success in data visualization. Try to perhaps persuade them to pursue careers in data visualization. And for example, I show them the following graphic, which is the most viewed story ever in the history of the Washington Post. If you go to several news publications that we usually consider the gold standard in the use of data visualization in the media, such as the New York Times or the Wall Street Journal, the Financial Times, the Washington Post, they will tell you that many of their most popular stories in their entire history are data visualizations. And this is the most popular, the most viewed story ever in the history of the Washington Post. Probably most of you have seen it. It's a graphic that was published at the beginning of the pandemic, trying to show what happens in a population if that population takes measures against a pandemic or doesn't take measures against that pandemic. So the little circles that you're seeing are representing fictional people that are passing the virus one to each other. And if a population establishes certain measures against a pandemic, such as social distancing or the use of masks, then the spread of the pandemic stops or lowers, becomes slower. This will be just a mere anecdote if we didn't have a lot of evidence to show that data visualization is extremely popular. Like, readers love to see data visualization. A few months after this story was published, the Washington Post published a job offer because they were expanding their visualization department. And in the job posting, they disclosed the following fact. Out of the 7 most visited stories in the entire history of the Washington Post as a newspaper, out of 7, 6 of them were stories that were produced by the graphics department of the Washington Post. There is power here, right? Those of us who can design data visualization to communicate, to express ideas, we have a lot of power, right, to communicate clearly. So I try to encourage my students to dig deeper into this language just because it is so powerful for communication. I also sort of like talk a little bit about the basic principles of data visualization, right? Why do we visualize in the first place, right? Well, we visualize in the first place, and one of the reasons why visualization is so powerful as a tool for reasoning and for communication, that is related mostly to how our visual system works, right? How our brain, how our eyes evolved to detect patterns in the world, right? So if I show you a wall made of bricks and all those bricks have exactly the same size, the same shape, the same color, you don't even need to think about it. Pre-attentively, your brain knows that all of them have exactly the same size and the same features. But if I change one of those features, right, your brain will also immediately detect that exception to the pattern. Well, this principle of the relationship between patterns and the exceptions to those patterns, that's what underlies data visualization. That is what data visualization at the core is really about. It's about displaying patterns, trends, right? Big pictures of data, and then also displaying the exceptions to those data, the outliers, the extreme values, the exceptions. These are not novel ideas, like 99.9% of the things that I write about or speak in presentations. This was already outlined and it was expressed by people who are widely considered pioneers in the history of data visualization, such as the famous statistician John Tukey, who back in the 60s and the 70s wrote a series of papers and also a book titled Exploratory Data Analysis, which is considered one of the foundational documents of modern data visualization. And in that book, Tukey said that the greatest value of a picture is that it forces us to see things that we cannot normally see. So the way that I explain the power of data visualization in my books and in my students in class is that I envision data visualization or think about data visualization in a similar way that I think about this pair of glasses that I'm wearing. If I take them off, I don't see your faces anymore. I see a blur, right? But once I put them on, then suddenly I see clearly, right? So in some sense, these glasses work as an extension of my perception. Data visualization is like that, and we should conceive of data visualization as that, as an extension of our cognition, as a way to see beyond what we can normally see. And data visualization is based on a very, very simple idea. The grammar of this language is based on a very simple idea, the idea of encoding data. Most of what you do when you create a data visualization in Excel, Power BI, Tableau, Click, R, Python, any of the other tools that you use every day, is to encode data. What the program is doing in the background, whenever you load a data set and you click on Power BI, create a bar chart. What the software tool does in the background is to encode the data. It gets your numbers, it creates a bunch of bars, all of them the same size, and then it changes the height or the length of those bars, right? And we call that in data visualization the property of objects that changes according to the data. That's the visual encoding. You are encoding the data. You're changing a property of an object according to the data that you're trying to represent. In data visualization, we can use tons of different types of encodings. We can use angle, like in pie chart, or areas, like in bubble charts, or position, like in scatter plots, for example, or in dot plots, right? This is a language that we still use and that I still use in data visualization to teach my students. One of the ideas, by the way, that I try to instill in my students is the idea that data visualization is not magic. Producing good, decent, effective data visualization is a craft. It's a craft that anybody can learn. This is a graphic that was designed by a former student of mine years ago, who had 2 months prior of designing that display, had no experience whatsoever in data visualization. She had never designed a map or a graph or a chart, and 2 months into my class, she was able to produce this beautiful poster combining different types of data visualization to tell a data-driven story about financial instability among senior people in Florida. She investigated the data, she collected the data, consulted sources, and then she learned enough visual design in my classes in order to produce this beautiful display. So that proves that this stuff is not magic. It can take some work, though. So for example, yesterday when I was flying from Miami here, I received an email because the semester is almost ending right now. Today it was actually the last day of class. And I received an email from a student of mine last night who said, I have really enjoyed this course. I wanted to pull my hair out many times, but it has completely changed the way that I think about charts and design, right? There's no better praise for a professor to say something like this, not the pulling of the hair. I don't want my students to go bald, obviously, but changing their minds about how data visualization works and how to think about graphics and how to think about design. That is the goal of my class. He has changed, I have changed. So how I have changed, right? So let me tell you a little bit about what I'm writing in this new book that is coming out. The first thing that I have changed is that, or the first reason that I have sort of like tweaked the way that I think about data visualization or teach data visualization is a question that I receive all the time. Whenever I do classes at the beginning of the semester, right? Many of my students ask this question whenever I teach a workshop, whenever I do consulting for companies, I get this question all the time. What are the rules of data visualization? And I wonder, what do you mean rules, right? And I think that the obsession with coming up with rules that are set in stone in data visualization are related to the fact that most of the books that some of them probably you have read about data visualization, they are extremely prescriptive, right? They tell you, don't use pie charts are evil. Not true. And many other rules that are set in stone. Spoiler alert, most of the rules that you can read in any of these books, including mine, because mine is over there, these are just the opinions of people who have written these books. Many of these rules are not set in stone. They are highly context dependent, and in some cases, they don't even have any sort of empirical data behind them, right? So that's very important to remember. Even the most basic rules that we have probably heard about can be questioned. So let me show you an example. For many years, I taught that bar graphs must start at 0, right? I still do this. I still teach my students that bar charts should start at 0, but perhaps not for the reasons that you have in mind. So let me tell you first how I used to teach it. All bar charts should start at 0, right? Because if they don't start at 0, then the bars will be distorted, right? Like the graphics that you have over there with the X on top of them, those bar charts don't start at 0, and therefore that distorts the perception of the numbers that are being represented. So the rule seems to be all bar graphs must start at 0, right? So this is bad. Never do it. That's the rule. Never do it. However, at the same time, if you read any manual of data visualization, you have probably heard that this rule that graphs should start at 0 applies to bar graphs, but they don't apply, for example, to line graphs, right? This is a line graph that doesn't start at 0. And there's a little bit of reasoning behind these. Actually, in one of my previous books, How Charts Lie, the one that I spoke about last time that I visited here 4 years ago, I explained that if a line graph doesn't start at 0, that doesn't really alter the aspect ratio of the line, right? How steep the line is. So it doesn't really matter that you put the baseline at 0 or at any other level. That doesn't change the line graph. But it does change the bar graph, the perception of your bar graph. So it seems that we are in very good footing to keep maintaining the rule, bar charts should start at 0. However, we don't really know whether most readers, when they see a bar chart, they focus their attention on the overall length of the bar to make estimates about the numbers that are being represented, or whether they focus on the upper edge of the bars. There are some papers about this that I link from the presentation. If they focus, if we discover through empirical evidence that most readers, when they see a bar graph, they focus on the sheer height of the bar to estimate the size of those numbers, that's a good reason to maintain the rule, bar graph should start at 0. But if most readers, they don't focus on the sheer height of the bars, they focus just on the upper edges of the bar, that doesn't make the bar graph different than a line graph. And therefore, it is completely appropriate to keep the bar graph with a different baseline other than 0. Now, do I have an answer to this question? I don't, because there's still a lot of research to be done around these issues. But I still maintain the rule, bar chart should start at 0. But today, I explain to my students why I keep it. I give them the reasons for the rule, not just the rule, but I explain what underlies the rule. And what underlies the rule, or what I call the rule or the principle, is a matter just of logical thinking. Because the encoding that we use in a bar graph, the property that changes in a bar graph when we represent the data, is the height or the length of the bar graph. It's not the relative position of a dot, like it happens in a line graph. Therefore, out of logic, right, if the encoding is height or length, then to keep the proportions, it's appropriate to maintain the baseline at 0. So just notice that what I have just done. I have not changed the teaching that much. I still teach them, I still encourage them to say, you should use a baseline of 0. But I don't present that as a rule that is set in stone. I present it as a reasoning. One of the things that I have changed quite a lot in the past few years is that I don't focus, when I teach visualization, I don't focus on teaching rules. The same way that if I had to teach how to write correctly, I would not teach rules of writing. There are no rules in writing. There are principles, there are suggestions, there are conventions, there is reasoning. You should do this because, or I recommend that you do this because, and what comes after the because is what really matters. That is what develops a good understanding of how data visualization works. Another thing that I have changed is that I have become much more tolerant towards the big diversity in the world of data visualization. One of the most iconic and popular data visualizations ever published is this one, the warming stripes. Probably you have seen it already. It has appeared in the cover of The Economist magazine. You can see it in protests, people protest things against climate change. There's even the case of a guy who printed out the graphic and covered his electric car with it. That's a little bit excessive in my opinion, but the graphic was extremely popular when it was published. It's very iconic, very popular. It has appeared on TV, on T-shirts, on clothing. It has appeared everywhere. You know what my first reaction to this graphic was? WTF. What is that? It doesn't have axes. It breaks the rules. It doesn't have labels. That breaks a rule, right? It doesn't have a title. It doesn't tell me what the colors represent. Where are the classes? What is the legend to explain the colors? Blah, 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 blah. Until I realized, particularly because I talked to the author for The Art of Insight, who is one of the people who I interviewed, Ed Hawkins. Ed Hawkins, who is a climate scientist in the UK, knows nothing about rules of visualization. And when he designed this very iconic graphic, what he wanted to design was actually an iconic graphic. He wanted to design just a beautiful graphic that he could bring to a conference, project it in the background while they were talking about something else. He wanted to create a very iconic image to attract people's attention towards the data that he was talking about, which, by the way, is climate change, right? The colors here represent the average temperature of the world between the 1880s and the present. The redder the color, the higher the average temperature of the world is. So the goal that he had in mind was not to create something analytical, right? A graphic that lets you explore data or analyze the data. It was not to create something that more journalistic, which is the types of graphics that I create, something to tell stories, to communicate an idea. No, he didn't. He just wanted a beautiful picture. And I think that he succeeded at that. The proof is that his graphic became extremely popular. I would ask you, what is it that is most likely that you will pay attention to? The graphic on the left or the graphic on the right? Probably the graphic on the right, right? Now, that doesn't make the graphic on the left worse. It just makes the graphic on the left different because it has a completely different purpose. Purpose is a word that I use all the time in my classes. What is the purpose? Who is the audience? What do you want to achieve? Depending on that, you will make one decision or you will make another decision. The graphic on the left, by the way, is called the, this is working. There you go. That graphic over there. That is called the hockey stick chart, which is also extremely iconic graphic. It was published back in the 1990s, but its purpose is completely different. Right? The designers of this graphic, a bunch of climate scientists, they also wanted to create a very iconic, eye-catching, striking image, but they wanted to create something that was a little bit more granular, that actually showed the data, the variation, the uncertainty around the trend lines, what is reconstructions of temperature, that's the blue line, what are actual records of temperature, that's the red line. It has a lot of context. It's more analytical. It's more like a graphic that a statistician will design. The graphic on the right is completely different. And that leads me to believe that we can talk about dialects of visualization. Visualization is a language, right? It has a grammar. Actually, one of the most popular, most important books in the history of data visualization is actually titled The Grammar of Graphics, which talks about the symbols that we use, the encodings that we use. That's all the grammar. But that grammar can be used for many different purposes, sometimes to create an iconic image, sometimes to create a graphic that tells a story, like the graphic that my student Deb Pang Davis designed for my class years ago. We can think about visualization, about the properties of visualization over several different axes, right? I created here a very simple diagram that will illustrate what I'm about to say. Some visualizations are more explorative in nature. We create them to explore data, right? Business dashboards, for example, right? Interactive business dashboards. The purpose of that is to sort of like explore the data, slice and dice the data. In that case, they are more exploratory or explorative in nature. The graphic that my student designed is not explorative at all. It's not interactive. It's completely static. Therefore, it cannot really be explored. But it is more expositive. She tries to tell a story, and therefore, that little dot in there, as you can see, moves a little bit to the right to indicate that it's higher on exposition. And it's also explanative in the sense that she doesn't just want to present the data, she wants to build an argument with the data, to make a case. And that's the reason why I call that more explanative or explanatory. And she was also trying to arouse some sort of emotion on the reader, right? She wanted to create an emotional response on the part of the reader. On the other hand, the graphic on the right, Ed Hawkins's graphic, is very high on the emotive scale and very low on all the other scales. I believe that it is useful to think about visualization like this because what I have observed throughout the years is that people tend to be too judgmental about the graphics that we see. And one of the mistakes that I call myself out in my own book is that in the past, I have been too judgmental myself. Sometimes I have evaluated or assessed graphics such as Ed Hawkins's warming stripes graphics with the same parameters, with the same principles that I would apply to grade my students when they are designing a graphic that is more explanatory in nature. And I cannot do that because they are two completely different creatures. They're not completely different. They share the same grammar, the same core of symbols and grammatical principles, but they are applied or they are used in two completely different ways. So pretty much like writing, right? Visualization design is not about applying rules, right? It is more about making decisions, making choices. Right? Those choices need to be justified somehow whenever we're designing a graphic. We need to justify them, for example, ethically, right? We need to think about the data that we are presenting, who is being represented or not, and so on and so forth. We can also justify those choices functionally. What is it that we want to achieve? What is it that we want people to be able to do with the graphic that we are presenting to them? But also aesthetically, just want to design this damn graphic because it looks great. And I want people to be able to pay attention to the data. That's a perfectly valid purpose for a data visualization, depending on what the goal of the graphic is. It's always, always dependent on this purpose, always considering goals and also considering constraints, such as, for example, the platform or the display that you're going to use to show your graphic. So this is a change, a huge change in the way that I teach visualization. I don't teach students how to apply rules. I teach them to justify their choices, because I ask them questions. Why did you do this? Why did you do that? And they better be prepared to justify their choices in a way that they will persuade me, based on empirical evidence sometimes, based on the reasoning about the data, based on multiple factors. Justification. Decisions in visualization are very subjective. This is actually a line in the book. Decisions in visualization are always subjective, but they should never be arbitrary, right? This is a very, very important concept to remember. For every decision that we make in a visualization, there should be a reason that we could present to others to persuade them about the sort of like the soundness of that particular choice. Let me show you an example just to illustrate very quickly how I teach these. Right? How I teach students, how to illustrate to students how to do this. One of the techniques that I use, one of the tricks that I encourage my students to apply, and this is perhaps an exercise that you can apply once you get home. Whenever you see a visualization anywhere, in the newspaper, online, etc., try to reverse engineer it, right? Try to put yourself in the shoes of the designer who created that graphic, and try to think about what steps, what decisions would I make in order to reach this particular point, in order to reach this particular visualization. What are the assumptions and the reasons behind every single choice? And in order to do that, I decompose tons of different visualizations. This is just one of them. This is a graphic that was published by the American Society of News Editors, which is an organization that every year conducts a survey among newspapers, asking newspapers about the composition of their workforces, right? How many white people, African Americans, Asian people, etc. you have in your workforce? How many women, how many men you have in your workforce, and so on and so forth. And a few years ago, they partnered up with a visualization firm called a Polygraph in order to create graphics for this survey. And this is one of them. You can see that it uses tons of bubbles, etc. One exercise that I do, by the way, with my students every semester is to show them several graphics and ask them to identify the encodings in that graphic, right? And the encodings here are position, as you can see on the horizontal axis, right? Bubble area encodes the size of every newspaper in the data set. Color and color shade, all right? That's also used to encode the primary data, which is the percentage of men versus the percentage of women in each one of these newsrooms. As you can see, the distribution is extremely skewed, right? Most newsrooms in the United States have many more men than they have women. And only a few of these publications have more women on staff than they have men. This is the 50-50 split, and this is the average, right? That message is reinforced through the color. I'm getting ahead of myself a little bit. So I decompose this graphic, right? I tell them, well, when I saw this graphic, I tried to put myself in the shoes of the designers. What decisions would lead me to a graphic like that? Well, the first goal of a graphic like this is to show the distribution, right? I have my data set, percentage of men, percentage of women. So in order to show that, I can simply create a very simple dot plot or a strip plot. This is called a strip plot, right? Showing the distribution. Now, why a strip plot rather than a histogram? That's a question that I can ask myself, and I can answer that question because I want to preserve the individuality of each one of these points, right? I don't want to aggregate the data. The data set is not very big, therefore I am able to show every single observation. I'm giving a reason. That's a reason. I want to preserve each one of these observations as an individual. Therefore, I prefer to use a strip plot rather than a histogram or a violin plot or a box plot or the many other ways that we have to represent distributions. But you know, I don't know, that looks so boring. There's black and white, right? And not only that, I mean, some readers probably will miss the main point that I'm trying to make, which is that most of these organizations have more men on staff than women. So maybe I want to vary the color, right, in order to emphasize the main message. The emphasis is the reason. I'm going to add color, not only for aesthetics reasons, in order to make the graphic better, although that's a good reason, but also to emphasize the main message that I want to show, which is the imbalance between men and women in these newsrooms. But maybe I'm losing a little bit of detail over here, so instead of just showing the data using hue, red and blue, right? Maybe I want to introduce a little bit more of granularity here, and maybe I want to play with the shades of the color, right? That will also make the graphic more visually interesting. I'm giving reasons. I'm giving reasons that can be discussed, that can be debated about in a meeting, for example, if this design was the product of a team working together. And after that, the problem with this graphic, I will tell myself, is that we are not giving readers an impression of how big or how small these organizations are. All of them look the same. But obviously, it's not the same to compare, the Wall Street Journal or the New York Times, which have huge workforces, in comparison to the local newspaper in, Detroit, Michigan, for example, which probably the staff will be much smaller. So maybe we may want to vary the size of these objects, right, according to the representation of the size of these newsrooms. I'm giving myself a reason to make that choice. But now I look at that and say, there's a problem here, right, which is that the circles are so close to each other and the bubbles are so big that they obscure each other. That doesn't look good. Because remember what I said before, I want to be able to see each individual newsroom. Therefore, I'm going to vary not only their horizontal axis, which shows me the distribution of the data, but also the vertical axis in order to be able to tell them apart. I began with a strip plot, the first graphic, and I ended up with what we call in visualization a bee swarm plot. We love cute names in data visualization for our graphics, right? So let me show you a diagram that appears in the book because it deals with this decision-making in visualization. Some decisions that we make in visualization have to do with the nature of the data itself, right? This is a distribution. Therefore, there are certain decisions that we will make based on that. There are certain decisions that are made based on how the graphic forms that we use, the encodings. Position is a very good encoding when we want to sort of like make very accurate estimates based on the data. I'm not going to get into the weeds on that because it will take forever. But some decisions in visualization are related to aesthetic considerations. This looks very boring, it looks really gray. Let's make it a little bit more colorful. Not too much though, right? Let's not go overboard with that. And let's try to associate the color also to something also important, which is to emphasize the main story. That's another very good reason to apply color here, to emphasize the main point that we're trying to make. And then some decisions are related not only to aesthetics, but also to the legibility of the graphic, make the graphic more readable. Now, does this take longer than just loading the data, going to Power BI and clicking on a button? It does take much longer, but it will make you a much better designer. Now, I encourage the students also to ask themselves several questions whenever they design a visualization, right? That was just an introduction, but then I go into sort of like a lot of detail. For example, details about how to choose graphic forms, how to choose encodings, right? Should I use length, height, position, color, etc.? How to make that type of choices. I go into a lot of detail about that into previous books, and I still, show my students resources that I have been recommending throughout the years. These are two very good websites that can help you make that type of choice, right? For every type of message, there may be 2 or 3 graphics that are more appropriate than not to communicate that message, right? One of them is the Data Visualization Catalog, which is an excellent website, very good for beginners, right? To learn the language of data visualization. And another one is the Visual Vocabulary, which is a poster that was designed. You can find these resources online. They are both free. The Visual Vocabulary is a poster designed by the graphics department at the Financial Times that classifies the main types of data visualizations that we use commonly according to the purpose that they are usually used to serve, right? So some graphics are better at showing comparison. Some types of graphics are better at showing distribution. Some types of graphics are better at showing geographic patterns in data. And according to that, you may have all those choices. So I still recommend these types of graphics. However, the danger is that the students may end up sticking too closely to these recommendations. I want to avoid that because, again, designing a visualization is not applying templates or applying rules. It's about the thinking. So I show them a lot of examples of how to think about data visualization. I mentioned pie charts before. So let's take a look at a pie chart. This pie chart was designed by a client of mine years ago. Whenever I work for clients, I ask clients to send me examples of their work so I can gently critique them and use them as examples to illustrate the things that I teach about. So this is a graphic that shows migration to Greece. Of all the migrants who arrived to Greece in 2016, where they came from, right? So even if you don't read the numbers, right, which is something that I'm going to ask you not to do for now, right, or I should have hidden them, you will see that nearly half of the migrants who arrived to Greece in 2016 came from Syria, around 1/4 came from Afghanistan, and then the rest came from other countries. Now, related to the question that I mentioned before that I get all the time, what are the rules of data visualization? I get usually another one. Do you think that this is a good graphic or a bad graphic? Because I'm supposed to be an expert. I said, I don't know whether it is good or bad. If I don't know, what are you trying to communicate here, right? So when I was presented with this graphic, I asked my client, what is it that you wanted to communicate? I'm going to give you several answers. I'm going to anticipate. Are you trying to show, when you design this graphic, were you trying to show that nearly half of these migrants came from Syria and another half came from other countries? Is that what you wanted to communicate? That half versus half? And they say, yes. They said, this is perfectly fine. This is a perfectly fine graphic. It communicates that very clearly. The only changes that I would make here will be aesthetic changes, changes in the color to further emphasize that message. I will color Syria with one color, and I will color all the other countries with a single color. I will preserve the separation, a white line separating the segments, but I will color Syria in blue and the other countries, for example, in a more neutral color, for example, gray. If that is the purpose, then this graphic works. But what if, and I love what ifs in my classes, what if your purpose were not that? Let's transform this into a class exercise. What about if the purpose of the graphic that you are designing is not to show parts of a whole and half versus half? What about if the purpose is to compare these segments to each other? Now, if you don't read the numbers, I can guarantee you that comparing these segments to each other will force you to squint and use your fingers and move your fingers around in order to compare the segments. We have a lot of evidence to show that pie charts may work well for certain things, but they are certainly not very good when the purpose of the graphic is to compare. If we want to compare, maybe a bar graph may be a better solution, right? Perhaps. And what about if the purpose of the graphic is neither to show half versus half, nor to compare or rank these countries to each other? What about if the purpose of the graphic that you're designing is to show, I don't know, some sort of geographic pattern in the data? There's no geographic pattern, but let's suppose that there is a geographic pattern worth highlighting here, for example, and this is all imaginary, but let's suppose that there is a correlation, an association, better said, between proximity to Greece and number of migrants arriving to Greece from those countries. Maybe that relationship exists. That's a geographic pattern, in which case the type of graphic that we could use to display that will be a map. And a map will serve another purpose, which is to locate these countries, because not everybody knows where Pakistan is, or even Afghanistan or Iraq. So based on that very simple exercise, I have just introduced you to this very notion of what I like to call in my classes not working in autopilot. This is one of the worst mistakes in data visualization. And I can guarantee you that this happens to everybody. It also happens to me. I have done this exercise plenty of times in my classes. I give a group of students, a data set in which everything adds up to 100%, and I ask them, please design a graphic. What type of graphic? Many of them come back to class with a pie chart. Why did you use a pie chart? I'll ask. And they reply, because everything adds up to 100%. Wrong answer, because that is not the purpose. That is not the purpose. That's just the nature of the data. And if I give them a data set that includes, for example, a geographic variable, such as countries, states, cities, I can guarantee you that many of them will come back to class with what? With a map, because we associate locations with maps. And as this very simple example with a very simple, very small data set shows, the same data set can be represented in tons of different ways, All of them appropriate depending on what we want to show. This is the deliberate thinking that we need to learn to apply in data visualization. Becoming a good visualization designer, again, is not about applying rules. It is about this reasoning, this justification, what I'm trying to show, who is the audience, what is the nature of the data, and so on and so forth, right? I also encourage them a lot, and I mean a lot, to think about design, thinking about visual design, meaning typography, color, composition, balance, hierarchy, emphasis. All those are principles, basic principles of graphic design. So I teach elementary principles of graphic design. But I'm extremely pragmatic, so I don't teach principles. I show them how to apply those principles, right? So I'm going to show you one example that I use in my classes all the time. I got permission to use it. This was designed by a group of graduate students, PhD students, and faculty at the University of Miami. Years ago, I was asked to teach an introduction to graphic design workshop for science students. And as I always do with clients, I ask them, send me samples of your work so I can take a look at them, gently critique them, and perhaps even redesign them. And a group of students sent me that research poster. This was a poster that they had presented at a conference. It's a poster about a research project that happened in the Amazon region. It's a poster about malaria, right? Malaria incidents in Latin America, particularly around the Amazon, right? Now, I gently critique this graphic, and I mean gently because I try to see, whenever I criticize something, I try to see where the student comes from, and I always try to express this idea, which is completely true, that every single thing that I'm going to point out here is a mistake that I have made myself, right? So, for example, as you can see, the poster looks very cluttered and very busy, very text-heavy, right? So that is an indication that we may need a little bit more of what we call negative space, margins, bigger margins. Maybe those background boxes, you can see that the poster is full of background boxes, right? One little rule of thumb that I teach my students is to think carefully about boxes. What are boxes for? What is a good reason to use a box? Well, around an object. If you want to emphasize it, if you want to separate it from other objects. If you box out every single thing in the poster, nothing will be emphasized. Therefore, you are defeating the very purpose of using boxes. So we can remove those boxes. I said in the workshop. Maybe we can do a little bit about something about that text. We will go back to that later. That map over there, maybe we can do something about it, right? It looks really light, and perhaps we can cut it off like that. We can frame it like that, just to add, create something that looks a little bit more consistent. Then I move here, and I love to make fun of software defaults. One rule of thumb that I teach my students isn't really a rule of thumb. It's more like a personal preference. I truly hate, and I mean hate, to be able to tell what software tool was used to design a particular graphic. And I can tell that is PowerPoint 2007, probably, something like that, right? Software defaults are evil. They need to be defeated. And this is true of any software tool. That doesn't apply just to Excel, PowerPoint, Power BI. I love all those tools. I have friends who work in all those companies. But software defaults are evil. We need to show, perhaps it's a little bit of personal quirky philosophy on my part, but we need to show respect for the reader. And to show respect for the reader needs to have the impression that the graphic has been designed by another person, not by a computer. And when we preserve software defaults that are not that great, such as that one, we're giving that impression that was created by a computer. Not only that, but if you take a look at that diagram over there, you will see that what is emphasized the most is the bubbles, not the labels inside the bubbles, right? That defeats the whole purpose of that particular diagram. What matters is the labels. The labels need to stand out, not the bubbles surrounding those things. And not only that, that diagram looks very unstable, looks like it's about to fall. We need to do something about it. More things. That is not colorblind safe, right? I have made this mistake tons of times. Always run your graphics through a color blindness simulator. There are many free color blindness simulators out there who will help you to do that. Learn a little bit about accessibility in visualization. It's really important. And also, take a look at that. I'm going to just, by the way, let me make an aside. All the jokes, little jokes that I'm making, I'm not joking about the students. I'm joking about the graphics. This is also super important. And I made that extremely clear when I did the critique. Everything that I'm pointing out here is something that I have done myself. I said, take a look at that scale. I'm going to challenge you. Find for me on the map the color that corresponds to 137. You cannot do that, right? Just because we know that color as an encoding is not great for detail, right? Colors are usually used in visualization when we want to show more or less, but not how much more or how much less. If we want to show that, we need to use another that type of encoding, not color shade. Therefore, for a scale like this, I said, this is what happens when you let, I think that this was created in Python, Python's evil defaults make decisions for you as to how many subdivisions you need on that scale. You need to make deliberate choices about that. Average. What is the average incidence? What are the, the standard deviations or the quartiles, right? You don't need anything more on that scale than the minimum value, the maximum value, the average value, and perhaps a couple of values in between, nothing else. But you need to impose that on the software. You need to make that deliberate. The word deliberate is extremely important in design as it is important in writing. That deliberate decision. And then I moved to my favorite part, which is this bar graph. I said, rhetorical question. Why is that damn bar graph so gigantic? It's only 2 damn data points. Why is it so large? And I said, I can tell you why, because I've been there, done that plenty of times. You are designing your poster, you have all the elements, your beautiful map, your beautiful charts, and you suddenly discover, very close to the deadline, that you have a huge hole in one part of the poster, and you don't know what to do with that. And what do? You blow up that graphic. You're all laughing, you know where I'm coming from. We have all done that, right? Bad choice. It's a bad choice. That graphic doesn't need to be that big. Not only that, why does it have a damn legend rather than labeling things directly, right? That's another little principle about visualization design. Whenever it's possible to label things directly, it is better to label things directly rather than using a legend, right? The legend will be appropriate if we had several bar graphs similar to each other, next to each other. Then labeling every single bar will make the bar graph look busy, and therefore we need legend. But if we only have one bar graph, we can simply just label the 2 bars. Deliberate decision, deliberate thinking, and always thinking about the reader, the experience of the reader. How the reader will react to that, how the reader will read this graphic. In any case, I could go on and on because we had a lot of fun with these, and I did a quick makeover of the poster, applying all these principles, increasing negative space, increasing margins, removing boxes. I only kept one of the boxes. I couldn't change the color palette of the original map because I didn't have the access to the underlying data, so I simply preserved the original map, but I recommended them not to use that color palette that is called the rainbow color palette, and it's a terrible color palette because it's a categorical color palette that is used to represent a continuous variable. So it might be better to use, for example, a monochromatic color palette, for example, or a bichromatic color palette, right? You could sort of like put the average in the middle, and you can use one color for above the average and another color for below the average, and then you can play with those 2 shades. Deliberate decisions, deliberate decisions, deliberate decisions. And finally, another thing that I have changed in my teaching is that even if what I teach is visualization design mostly applied to clear communication, so most of my students are not journalists, by the way. Even if my class is a journalism class, most of my students are data scientists and data analysts who want to learn how to tell stories with data, how to become better designers in data. Sometimes they want to pull their hair because I usually make them work really, really hard to learn all these principles. I make them do a lot of exercises. So even if what I teach is what we could call effective communication, journalistic visualization, storytelling with data, I try to open their eyes to the fact that visualization doesn't always need to be clear and efficient. Sometimes, again, depending on the purpose, visualization can prioritize other goals, depending on what we want to achieve. Let me show you an example, and I will close the presentation with that. This is my friend Jaime Serra. He's another person who also appears in The Art of Insight. Jaime essentially has a similar background to mine, right? He has a background in graphic design, a background in journalism, but he is also a visual artist. He creates paintings based on data. He creates data art, and he has done tons of exhibits all over the world with the data art that he creates, sometimes using data that he generates himself. Years ago, and this is one of the graphics that I showcase in the book, Jaime, who is a very heavy coffee drinker like I am, wanted to visualize how much coffee he drinks throughout a year. Now, I'm not particularly creative. If I had to do that, imagine that this is the mug that I use every day to drink my coffee. Probably what I will do if I want to measure how much coffee I drink every day, I will get my mug, draw some sort of a scale over here, ounces of coffee, and whenever I pour coffee inside, I will measure how much coffee I'm drinking, and I will rush to my computer, go to Excel, and I will say, January 25, 2023 or 24, this number of ounces of coffee I'm drinking this day, and then at the end of the year, I will design a line graph, which is the type of graphic that I usually use to represent change over time, because it will be a graphic that will allow me to see trends and patterns in the data, seasonality of the data. Are there months in which I'm drinking a lot of coffee, less coffee, more coffee, less coffee, right? I will think about an analytical graphic, a graphic that will allow me to either understand the data better myself or to communicate that data to others. That's how my brain works, right? But Jaime's brain works in a different way. Jaime is more an artist, who said, I don't really want to create a boring line chart. So what I'm going to do is like get 12 pieces of paper. He got 12 large pieces of paper. He folded one per month, and then he folded those pieces of paper to subdivide them into quadrants with the folds, like pages on a calendar. And then when he drank coffee, he always tried to spill a little bit of coffee in order to some of the coffee to accumulate down here, and then he'll position the coffee mug on the corresponding quadrant of the corresponding day of the week and of the month. And the result was a physical data visualization of coffee drinking patterns throughout a year. Now, I can still argue that this has some analytical virtues, right? We can still see months when Jaime was working really hard, probably drinking a lot of coffee here. Then probably here he was taking a vacation at the beginning of the month. Then here, that's probably another vacation. This is probably another vacation. We take a lot of vacations in Spain. I really miss that. And we drink a lot of coffee as well. But the main purpose here is not analytical. Even if we can still see the patterns in the data, the purpose of this graphic is not to display those patterns. It's to create something fun, something eye-catching, something beautiful, similar to what the warming stripes achieve. Now, most of you work in analytics, so you're probably thinking, how is this related to what I do? I'm never going to design a graphic like this in my life. Well, maybe you will. Try to imagine, just for the sake of argument, that, for example, you're creating, a quarterly report, right, in which you're going to analyze data from the company, whatever. And let's suppose that the topic of that report is, perhaps you want to analyze how much coffee people drink in your company, right? And you gather the data, you analyze the data, and then you create a report, a PDF or print report. What do you put inside, on the inside pages of the report? The types of graphics that I create or that you create are line graphs, bar graphs, you slice and slice the data, scatter plots to correlate coffee drinking versus whatever other variable, analytical graphics. But what do you put on the cover? You put that, because that catches people's attention much more than the other types of graphics. You will use a different dialect of visualization on the inside pages than the dialect that you will use to design the graphic that goes on the cover of your report. So just to summarize, we use written language, and I'm a writer, right? I'm a writer. We use written language for multiple purposes. We use the same grammar for different purposes. Sometimes to communicate clearly, sometimes to explore, analyze, think, because one of the best ways to think clearly about something is to try to write about something. The sheer process of forcing yourself to write about a topic clears your thinking about that topic, the same way that visualization can also clear our thinking when we visualize something. But sometimes we use, language just to arouse emotion, right? Perhaps we want to create something that is more poetic, right? So depending on the purpose, written language can be direct, Spartan, sparse, just because we want to communicate clearly. Sometimes we use a style that is a little bit more free-flowing, right? More tentative, more essayistic. In some cases, more playful or more poetic, right? But it's the same grammar. It's only that we are using different dialects of the same language. So I wonder, why should be visualization different? Why cannot we approach visualization in a similar way that we approach writing? Thank you so much. It's a pleasure to share time with you again. I don't know whether we have time for questions or I should leave. Maybe the organizers can let me know. Nobody? I will take a question. We still have 5 minutes, right, before the end of the session. Any questions? Yes. Oh, we have a microphone over there. So we are supposed to take questions. That's a good thing.
Hi, David Corliss, OnStar Insurance. One of the most talented people I've had a chance to work with, for all I know she's hiding around here someplace, Virginia Harlow, a very interesting background. Worked with her at 2 different companies, actually. But her background originally was in graphical arts, and then she went into IT, worked as a project manager and did a number of things. But her original grounding was in graphical art. She started as a commercial artist and then went into other things. But she always brought that perspective to her work, and it really, really stood out. And I know that my work as a data scientist, when I worked with her, it was much better. When I think it's still better now. It shows the influence of that artist that I used to worked with for a number of years. Mm-hmm. Do you think there's a place for that in the large companies we have, in the large teams? I mean, if you're working in some mom and pop shop and you've got 3 people, that might be different.
Yeah.
But should we be seeking out graphical artists specifically to work on IT teams, on data science teams, to bring that perspective?
The answer to that question is that if you can afford it, having someone with knowledge of visual design is always beneficial. Because again, they can help you move from these, which is good. It's not a bad poster by any means, right? But it could use polishing in the design, right? The sort of like the stylization of the graphic, and move you towards something like these, right? They can help you improve the fonts, the colors, the spacing in your layouts, So if it is possible, the answer is yes, right? Any team that designs visualization, I think, should be multidisciplinary as much as possible. And going back to the world where I come from, the world of journalism, if you take a look, for example, at the composition of the graphics department at the New York Times or the Washington Post, their backgrounds are very varied. You have journalists, reporters, you have designers, you have cartographers, you have statisticians working in graphics department, because as you said, each one of them brings a different perspective to the job, and they reinforce each other. And I have experience teaching different types of backgrounds. I usually joke that whenever I teach scientists, like in this case, I put a lot of emphasis on the design side of things, right? Fonts, color, and so on and so forth. But I also teach journalists, and when I teach journalists and graphic designers, right, I don't teach them about visual design because they are supposed to know about that already. I teach them about the data science part of things. Don't simplify things, right? What is a distribution? What is a standard deviation? How to display it? The importance of not showing just the average, but also the distribution. That's sort of like the data science part of things, right? Each one of my books actually focuses on something different, on one of these aspects that I'm talking about. So the short answer is yes. A multidisciplinary team, having someone with not necessarily a professional graphic designer, but someone who has that sort of like that sensibility towards colors and matters related to design is always beneficial, I think. Yeah, absolutely. All right. thank you very much again for having me. Oh, there's another question over there. Yeah, sorry about that. I didn't see you.
My name's John Desharon. Just looking at like continuing education, I know you said you work for the university, so do you recommend people looking at master's programs, looking at PhDs, or are there other smaller programs where you can get that more, I don't know, bang for your buck, so to speak, employer buy-in and those kind of things? Is there anything you want to speak to on that?
All right, so the short answer is that being from Spain and having enjoyed the luxury of a public education in Spain, for which I paid like $100 per year as tuition. One of the challenges in the US is the cost of tuition and programs, right? So certainly, if you can afford it, doing a master's degree, if you want to learn, will save you a lot of headaches. I usually joke with my students that my class, which is just the intro class, right? But all the students walk out of my class with a sort of like working understanding of how to design, good-looking data visualizations that are truthful and solid and that tell a story, right? All my students learn how to do something like this. So I joke with them that in 3 months, I teach them what took me probably a decade to learn on my own, right? So it saves a lot of time, but it is also very expensive. The way that I learn myself, I am self-taught. So and I tell this story in one of the books, right? It's like I stumble upon data visualization and infographics because I also do illustrated visual explanations. I wanted to work in radio. I worked in radio for a while, reading the news every morning in the equivalent of NPR in Spain. I still love radio. But I stumbled upon infographics, and I fell in love with the field, and I pulled my hair like my student here, but I did that on my own, right? Learning, practicing. So what I recommend today, fortunately, the landscape is completely different to when I began, right? When I began my career, there were very few books about data visualization. There was Tufte, for example. His books are excellent, but they are very narrow, right? They are applicable to just the specific fields of scientific visualization and statistical visualization, right? So they're very specific to that. They're not very helpful for other types of visualization. But today the landscape is completely different, right? It's open world, tons of different books that you can learn from. There are online courses also, tons of them, tutorials, tons of software tools also. At the very beginning of my career, software tools were difficult to access, they were very expensive. Today, you have tools that are offered for free, which is amazing. In some cases, they are even open source. I use some open source tools in my classes. But this is a craft, and a craft can only be learned by practicing the craft. So reading the books is not enough. Learning how to use the tools is not enough. You need to put those skills to work, right? You need to start creating graphics. Your first graphics are going to be complete crap, but that doesn't really matter. Just make them, right? Just practice. Put them out, get feedback, right? There are communities out there, right, that you can participate in, that you can submit a graphic and then the community will give you feedback. There's one called Makeover Monday. There are challenges, for example, the Storytelling with Data, which is based on Cole Nussbaumer's book. Her website also, she poses challenges. Let me see if I can find this slide with the books that I had a little bit later. So if you don't know Cole's book, it's a very good introduction, very brief and concise and well-written introduction to data visualization, storytelling with data. This company poses challenges. They get a data set, let's visualize it together, let's talk about it. Makeover Monday is very similar. There are many communities like that. So participate in communities like that. There is also the Data Visualization Society, DVS, right? They also have challenges all the time. So participating in those challenges is like practicing writing. You just practice, put things out, get feedback, go back to the drawing board. And then the best advice that I received in my career was when one of my colleagues in the newsroom where I learned to do visualization almost 30 years ago gave me a bunch of books collecting the work of many visualization designers, and he told me, copy someone. Copy someone not in the sense of plagiarizing anybody, but in the sense of take a look at the graphics that you like the most, try to reverse engineer why you like them, and then try to borrow ideas. And by combining things that you borrow from this person, from this person, from this person, from this person, And by practicing and getting feedback and working hard and pulling your hair, eventually you will develop your own sense of a style, your own way of doing things. So it's a long process, but it's a lot of fun. That's another thing that is great about a visualization. That is super, super cool and a lot of fun as well. Good? Good. Again, now, thank you so much again.